Hello, in this lesson we are going to cover what a Merkle tree is. I mentioned in a previous video when we was talking about the structure of a block in blockchain that Merkle trees are very important and they relate to hash algorithms. So if you're not quite sure what hashing is, then feel free to check out the lesson on what is a hash. Then come back to this video and we'll talk about how Merkle trees really do help the validity of transactions in a block within blockchain. So what is a Merkle tree? A Merkle tree essentially takes a bunch of input and it helps confirm its validity. So imagine if I have, in the case of Bitcoin for example, or blockchain really, I have 4 transactions. The average block in Bitcoin has over 2,500. So obviously this is just a simplification, but once you understand the concept with 4, 2, 8 or however many, the concept is just the same. And I'm going to call this T1, T2, T3 and T4. So these are 4 individual transactions and they obviously have their own information, their own unique ID, it's all of that cool stuff. And what happens is each one of these is fed through a hashing algorithm. The exact hashing algorithm isn't important in understanding the concept of Merkle trees, and it's always the same hashing algorithm for all of these. So this is a hashing algorithm, and from there what we get, drew in the wrong place there, what we get is the transaction hash. So the transaction hash, as we discussed in the hashing video, is different to the original transaction. A lot of the time it's a lot shorter than the original value, wherever it is, whatever file it is. So these are the hash values. So I'm just going to call it like HT1. Almost sounds like some sort of phone, like HTC1, HT2, HT3, HT4, and now these are combined into pairs. So what you get now is these are combined together, and the combination of these are fed through the hashing. Ooh, sorry about that. That wasn't a very good line. Through the hashing algorithm again. So hashing let me just undo that. Algorithm. And what I'm going to do is just remove some of this. Just so I have some more information, some more space to deal with. So the hashing algorithm. So these two are combined. They form a single piece of information. So they're just essentially stuck together. By combining them, we put them through the hashing algorithm, and then we get a combination hash. So it's a hash of hashes. So what I'm going to do is right here we get a hash of the original transaction, and then here we get a hash of hashes. So this is a hash of the hashes, and I'm going to call this, so new hash for example. Now I'm going to call it HH1, HH2, And then, let me get rid of this as well. Let me get rid of the title. And then, this is, again, combined. So this is combined. And the combination is fed into the hashing algorithm again. So hashing algorithm. And from this, we get the ultimate piece of information. We get a single hash. So, and this is called the root hash. The root hash. So I'm going to call this RH. And this root hash is the eventual hash of going through the Merkle tree with all of the transactions. Whether you have 4 transactions, you have 1,000,000 transactions, you have 2,000, however many you have, doesn't matter. You ultimately get to a root hash, and that's the whole point of the Merkle tree, is getting a root hash. So what this allows is, it helps prevent tamper within the transactions. Because if, let's say, one of these transactions was modified, so let's say we were a hacker and we modified transaction 1. Even one little change, even if we were to change just one bit of data, this would obviously be different now. And as a result, the combination of, let me choose a different color, of this would be different, which would lead to the hash of hashes being different. And then ultimately, this combination will be different. And then eventually, it has a massive cascade effect. And then the root hash is different as well. So this allows people to see if the block is valid. So that is one of the amazing things about Merkle trees. Merkle trees allow the checking of the validity of a bunch of transactions, or just data in general. So this is a very key part of blockchain and Bitcoin. There's not much to it other than that. If you have any questions, feel free to ask. If there's something that you didn't quite understand, then feel free to go over the video again. If you're still unsure about hashes, like I said, just go and check out the What is a Hash video. And as usual, thank you for watching, and I will see you in the next lesson.